Hello everyone, welcome back. Today we are going to take a journey through time and see how our understanding of the atom has evolved from tiny indivisible sphere to complex quantum models. So let's begin with the revolution in atomic theory. So in this video, we will cover Dalton atomic theory, Thomson plum pudding model, Rutherford nuclear model, Bohr's planetary model, and at the last, we will compare the evolution of atomic model. So far, we have learned that matter is made up of atoms. But how did scientists first come to this idea? Let's go back in time and look at Dalton atomic theory, which was one of the first attempts to explain the nature of atoms. So, John Dalton playing a vital role in laying the foundation of modern atomic theory. He introduced the concept of indivisible atom into science. So, John Dalton, known as the father of modern atomic theory, he gave the first modern theory about atoms. He explained what atoms are and how they combine to form matter. Here are main points of Dalton atomic theory. All matter is made up of tiny particles called atoms. Just like wall is made up of bricks, everything around us is made up of atoms that cannot be created, destroyed, or further subdivided. This theory is based on law of conservation of mass and law of constant composition. In my previous video, I had already explained this concept, but let's quickly go over it again for better understanding. So, here are few points which cover Dalton theory. First is indivisible atoms. So, atoms are indivisible and indestructible. Atoms cannot be broken down into smaller parts. Second point of this theory is identical atoms of elements. So atoms of the same element are exactly the same in every way. Like all oxygen atoms are identical and all hydrogen atoms are identical. Third is chemical compound. Atoms combine in a small whole number to form compounds like water. So here are two hydrogen and one oxygen atom combine to form water molecule. They are not combined in fraction. They combined in small whole number. Next is conservation in reaction. So in a chemical reaction, atoms are just rearranged. They are not created or destroyed. Atoms shuffle to form new substance, but no new atoms are made or lost. So if you mix hydrogen and oxygen to make water, you are combining two hydrogen atom and one oxygen atom. The atoms are just rearranged, they don't disappear or break. Here is a quick tip to remember Dalton atomic theory easily. Dalton atomic theory. Just remember the word A S I C S. A stand for all matter made up of atom. S stand for same element, same atom. That means atoms of the same element are exactly the same in every way. Like all oxygen atoms are identical and all hydrogen atom are identical. I stand for indivisible atom. That means atoms are indivisible and indestructible. Atoms cannot be broken down into smaller parts. Next is C stand for combine in whole number. That means atoms combine in small whole numbers to form compounds like water molecule formed by combination of two hydrogen and one oxygen atoms, not in fraction. They combine in small whole number. Next, S is a stand for simply rearranged. That means in a chemical reaction, atoms are just rearranged. They are not created or destroyed. Atoms just shuffle to form new substance, but no new atoms are made. So, Dalton model laid the foundation, but it could not explain the internal structure of the atom. So, let's move on to the next atomic model to see how scientists improved it further. So, let's explore Thomson atomic model. J.J. Thomson discovered the electron, a tiny negatively charged particle inside the atom. He received Nobel Prize in 1906 for this groundbreaking work. After discovering electron, he wanted to explain what an atom looked like. So he gave a model called plum pudding model. You can imagine this like if you think of an atom like pudding. The cake part is made up of positively charged substance and the electrons are like plum or raisin spread inside it. So the atom is like a soft ball of positive charge with tiny negative electron stuck inside it, just like raisin in a pudding or seeds in a watermelon. So it is also called watermelon model. You can also think it like in chocolate chip cookies. The dough is the positive charge and the chocolate chips are electron. So the main point of this model is atom depicted as a sphere of positive charge and electron are embedded in it like seeds in watermelon. The total positive charge and negative charge are equal, so the atom is neutral overall. However, no concept of nucleus or concentrated positive charge has been given. No explanation for atomic spectra or radioactive has been given. J.J. Thomson discovered electron. He used a special experiment with cathode ray tube, which is a glass tube with air removed and metal plate inside. He connected two metal plates inside the tube. One plate is cathode, which is negative plate, and other is anode, which is positive plate. This is cathode ray tube. Now he applied high voltage across these plates. He noticed a beam of light appeared from the cathode and moved towards the anode. So what he observed with this experiment, the cathode ray moved from negative to positive. when electric and magnetic field were applied, the ray went towards the positive plate. The ray moved a paddle wheel showing they had mass. So with this experiment, he concluded the ray were made up of negatively charged particle. Negatively charged particle. This ray is negatively charged particle called electron. An electron present in all atoms, and atoms are not indivisible. He calculated the charge to mass ratio. Charge to mass ratio. That is, how much electric charge an object as compared to its mass. It is written as E upon m. E is the charge of particle and m is the mass of particle. For an electron, the value of E upon m is equal to 1.76 into 10 to the power 11 coulomb per kg. Because charge of an electron is 1.6 and 10 to the power minus 19 coulomb, which is an experimental value, and the mass of electron is 9.1 10 to the power minus 31 kg. So this is the mass of electron. Now we will get the value 1.76 into 10 to the power 11 coulomb per kg. So Thomson model was an important step, but it failed to explain the atomic structure properly. So scientists kept experimenting. That led to the next breakthrough, Rutherford model. The idea that electrons are embedded in a positive sphere did not explain how they stay stable and do not lose energy. This is the limitation of this model. So Thomson model was an important step, but it failed to explain the atom's structure properly. So scientists kept experimenting, and that led to next breakthrough, Rutherford model. Now that we have learned about Thomson model, let's move on to a very important experiment that changed everything about how we understand the atom. Rutherford gold foil experiment. This experiment gave us the first clue that atoms have a tiny dense nucleus in the center. Let's see how Rutherford discovered this. So, in 1909, Rutherford, with the help of his students, Geiger and Marsden, wanted to test Thomson plum pudding model. According to that model, the atom was an sphere of positive charge and electron embedded like plum in a pudding. To test this idea, they designed a famous experiment. He used a thin gold foil as a target. Alpha particles were emitted from a radioactive source. These alpha particles are positively charged. A fluorescent screen of zinc sulfide placed around the foil, which would glow whenever an alpha particle struck it. The experiment was carried out in a vacuum chamber to avoid disturbance from air molecule. If the positive charge was spread out evenly, like in a pudding, all alpha particles should pass through the foil with a very little deflection. But what they actually observed Most alpha particles pass through the gold foil without any deflection. Some alpha particles were deflected at small angles. Very few particles were deflected back at the large angle, even bouncing straight back. So what was the conclusion from these surprising results? That atom is mostly empty space because alpha particles went straight through. The second conclusion is there is a small dense positively charged center because some particles were deflected sharply when they come close to the dense core. Next is nucleus contain most of the atom's mass. So as only something very heavy could deflect the fast alpha particles. So what was the Rutherford's atomic model? It is like solar system model. According to this model, atom has tiny nucleus at the center that contain positive charge and most of the mass. And electrons revolve around the nucleus in circular path, just like planet orbit the sun. Atom is mostly empty space. Although this model was a big improvement, but it had one big flaw. According to physics, electron moving in circle should lose energy and spiral into the nucleus, making the atom unstable. But atoms are stable in nature. This was not explained by Rutherford model. Now we have seen shortcomings of Rutherford model. Let's move to the next major development, Bohr's atomic model. Let's understand that how Niels Bohr improved upon Rutherford's idea to give a more stable atomic structure. So, Bohr's atomic model explained how electrons stay in their orbits. This model is proposed by Niels Bohr. He modified Rutherford's model to solve the problem of electron stability. Now, let's understand Bohr's atomic model, which was a major improvement over Rutherford. He explained that electron revolved in a fixed circular path called orbits or energy level around the nucleus. Bohr's atomic model. So according to Bohr atomic model, electrons are revolved in a fixed circular path. These are the circular path of an atom. So electrons are revolving in these circular paths or energy levels around the nucleus. These orbits are also called shells and are labeled as K, L, M or N, or numbered as first shell, second shell, third shell or fourth shell and so on. So each orbit has fixed energy. So electrons in these orbitals do not lose energy, which explain the atom's stability. When an electron gain energy, it will jump from one energy level to another energy level, which is higher energy level, which is called excited state. And when this electron lose energy and jump back to the lower energy level, it releases radiation. releases radiation. So energy is absorbed or emitted in a fixed amount called quanta. So Bohr's model explains the stability of atom and spectral line of hydrogen atom. So that was Bohr's atomic model. It explained many things, especially about hydrogen atom, but still had some limitations. Like it worked well only for hydrogen and single electron atoms, and it could not explain spectra of multi-electron atoms and detail of fine structure of atom. Now, let's compare the different atomic models proposed by scientists over time and understand their limitation. This will help us how each model contributed to the development of modern atomic theory. So first, we have learned Dalton atomic model, which is also called solid sphere model. What was its key features? This model explained atom is indivisible, solid, and indestructible, but it could not explain subatomic particles or chemical behavior of an atom. Next improved model was Thomson's model, which is also called plum pudding model or watermelon model. This atom explained that atom is positive sphere with negatively charged electron embedded in it. That's why this model is also called plum pudding model. But it could not explain the scattering experiment of Rutherford, and it could not also explain about the nucleus of an atom. Moving to the next model is Rutherford model, which is also called nuclear model. This model explained that atom has a dense positively charged nucleus and electrons revolve around it. So this model explained about nucleus, but it could not explain the stability of atom, that why electrons do not fall into the nucleus. Next improved model was Bohr's model. This model is also called planetary model. It explained that electrons move in a fixed circular orbit, which are called shells or fixed energy levels. These shells are with quantized energy, but it worked only for hydrogen and single electron atoms. It could not explain the multi-electron atoms or fixed circular orbits. So each model helped correct the flaws of previous one and brought us a step closer to understanding the true nature of atom. So that was a quick journey through the evolution of atomic model from Dalton to Bohr, each one improving our understanding about atom. In the next video, we will move ahead and explore more advanced and accurate quantum mechanical model of atom. So if you found this helpful, don't forget to like, share and subscribe for more such easy explanation. And if you have any doubt or suggestions, drop them in the comment below. See you in the next video. Bye bye.